Hello friends, a famous proverb is there. The more that you read, the more you will learn. The more you learn, the more place you will go. So I think it is the right time to visit the place of scalars and vectors. I'm going to explain in this video about the dot product of two vectors. In my previous video, I explained different types of vectors, addition, subtraction, and some numerical problems also explained. So, in this video today I am going to explain about the product of two vectors. You know that the product of two vectors may be a scalar, may be a vector, because whenever we multiply two vectors, it will give a physical quantity which may be a scalar or may be a vector. That means the product of two vectors may be a scalar or may be a vector. Based upon that, the multiplication or product of vectors are classified into two types. One is the dot product, or it is called scalar product. Second one is the cross product, or we say it vector product. So today in this video, I shall explain regarding the dot product. That means when two vectors we are multiplying, if the resultant vector or the product is a scalar, then we use the dot product. For example, you see, suppose our work is the product of force and displacement. Force is a vector, here displacement is a vector, but work is a scalar. So in this case, I shall write W is equal to F dot S. I shall use the dot product, not the cross product. Here I written cross product. But since the result is a scalar quantity, so I have to use the dot product. So today I am explaining the dot product of two vectors. Already I have written the headings, dot product of two vectors. Suppose A and B are the two vectors. Let us see here. So I can say that if the product of two vectors is a scalar, then the product is the dot product. Okay? See here. Suppose this is the vector A, this is vector B. Now the angle between A and B is theta. Then the dot product of A and B can be defined as, okay, I am writing let A and B are two vectors and theta is the smaller angle between them. This is the smaller angle, because except that one more angle is also here, but I am taking the smaller angle. Then how I shall write the dot product? So A dot B, A vector dot B vector. I can write this is AB cos theta. So I can say that the dot product of two vector is the product of their magnitude and the cosine of the angle between the two vectors. So I can say that dot product, or we say scalar product of two vectors is equal to product of their magnitude and cosine of the angle between the two vectors. So, and cosine of the smaller angle between the two vectors. I have written here vector A dot vector B is equal to AB cos theta. Here A stands for magnitude of the, here A stands for magnitude of vector A. Okay. B stands for magnitude of vector B, and theta is the smaller angle between A and B. Let us see. Here I can say that I can write it as like this: A B cos theta. That means A into component of B, component of vector B in the direction of A. Otherwise, I can write this is B into A cos theta, or this is B into component of vector A along B. So you can write like this way. So that means you see that from here I am drawing one perpendicular. Suppose this is the X, this is the B. Here to here I can say this is B cos theta. Okay, and here to here this is A. So another way also I can define how the dot product of two vectors can be defined as magnitude of one vector and the component of the another vector in the direction of the first vector. So I can say that dot product of two vectors also or I can say that can be defined as the product of magnitude of one vector and component of another vector along the direction of first vector. This is the theta. You know that cos theta is equal to b by h, or I can say that cos theta equal to a by b, but a equal to b by, I can write here cos theta is equal to a by b, implies that a is equal to b cos theta. I have mentioned here. In this way also I can express. Now let us see some special cases. What is the special case? So I hope that you might have subscribed our channel. If you have not done, it is better to do it as early as possible. At the same time, I hope that you will share this video with your friends. As a result, they can also get the benefit. Okay, let us see. Now, suppose, okay, some special cases we'll see. Special cases. The first case, case 1. Theta is equal to 0 degree. That means the two vectors are parallel. Then the vector A dot vector B is equal to AB cos theta. This is equal to AB cos 0 degree. You know that cos 0 degree is equal to 1. So I can say that AB, since cos 0 degree is equal to 1. So I can say that if two vectors are parallel, then the dot product will be product of their magnitude. So I can say that if two vectors are parallel, then their dot product will be the product of their magnitude. This is the case 1. Second case we will take. Case number 2. Case number 2. Theta equal to 90 degree. That means two vectors are perpendicular. Like this way you can say that two vectors are perpendicular. In this case, I can say that vector A dot vector B is equal to AB cos 90 degree. This is equal to 0. Since cos 90 degree is equal to 0. That means already in lower classes you have studied that when a coolie is standing in the platform by carrying a luggage in his head, he is making 90 degree angle with the surface. That time we say that work done by him is 0. Okay, and in this case if I consider the unit vectors, for unit vectors, suppose I dot j or j dot k, unit vectors, or this is equal to k dot I, this will be equal to, see that I dot j, I am telling about the orthogonal system where the three axes are perpendicular. This I stands for the direction along the x axis, where j stands for the y axis and k stands for the z axis. In this case, I dot j, j dot k or k dot I will be equal to 0. In the previous case when I said that theta parallel, in that case I could write like this, I dot I equal to j dot j equal to k dot k cap, I cap, j cap, k cap. In that case, both cases it was parallel. Parallel means that is the cos 0 degree. So cos 0 degree is equal to 1. That means this is the one. This is the previous case. If I mention that. So this is the second case where theta is 90 degree. Now suppose theta equal to 180 degree. Theta is equal to 180 degree. So A dot B is equal to AB cos theta is equal to AB cos 180 degree. This is equal to minus AB. Since cos 180 degree is equal to minus 1. That means if two vectors are anti-parallel, if two vectors are anti-parallel, then the dot product will be negative product of their magnitudes. So 180 degree means this is the anti-parallel. So I can say that if two vectors are anti-parallel, then their dot product will be negative product of their magnitude. So these are the three special cases I mentioned. First, once again I am reminding, first case I wrote that theta equal to 0 degree. There we found that A dot B is equal to AB cos 0 degree. That means is equal to AB. Second case, when theta is equal to 90 degree, we found that A dot B is equal to 0. Third case, theta equal to 180 degree, we found that A dot B is equal to minus AB. These are the three special cases I mentioned for your better understanding. Let us see the dot product of two vectors in terms of the components. So children, if anything is there, you can comment. As a result, I can rectify my doubts, or I can try my best to be better teaching. Let us see. So now suppose dot product of two vectors in terms of the components along the coordinate axis. Okay? Suppose here A is a vector. So I can write that this is AXI plus AYJ plus AZK. This is J cap, K cap, I cap. All cases where I will mentioning the I, J, K, these are unit vectors for direction. So at all time caps are there or a hat is there. Whether I mention or not, you have to think that. Suppose the second vector B is equal to Bxi cap plus Byj cap plus Bzk cap. Okay. Now let us see. So A dot B is equal to, so now I can write Ax Bx I cap dot I cap. Next one plus Ax By I cap dot J cap plus Ax Bz I cap dot K cap. Similarly, now I can write Aybx J cap dot I cap plus Ay By J cap dot J cap plus Ay Bz J cap dot K cap. This plus Az Bx K cap dot I cap plus Az By K cap dot J cap plus Az Bz K cap dot K cap. Say that this is equal to Ax Bx plus Ay By plus Az Bz. How it? You see here. Here I dot J, I dot K. This is 0. These are the unit vectors. I dot J. How? You see that I am writing I cap dot J cap. Okay. This is equal to I cap dot K cap. Here you see J cap dot I cap dot I cap. J cap dot K cap. This is also equal to K cap dot I cap is equal to K cap dot J cap these are equal to 0 because these are the unit vectors. I can say this is 1 into 1 cos 90 degree. This is equal to 0. Okay. So for that purposes I have mentioned this is ax, bx, ay, by, az, bz. Already you know that x, here I have mentioned the x, this is the component along the x axis. Vector x axis component, y axis component, z axis component. Similarly, vector d, this is the x axis component, this is the y axis component, this is the z axis component. So in dot multiplication I have multiplied the x component of A with the x component of B, y component of A with the y component of B, and z component of A with the z component of B. I hope that you might have understood. Okay children, let us see one example which will be make you more clear. See here, suppose one particle is there. You apply some force. If the particle displaced the distance r, that means this is the force, this is the displacement. Then the work done, we write it is the dot product of a force and displacement. Now one numerical problem I am giving you, I am solving it. See here. So this is an example. If a force of 10 Newton act on a particle, okay, no problem, act on a particle vertically upward and the particle displaced vertically downward 2 meter. That means this is the particle. You applied the force upwards, but the particle moved downwards. So here to here the particle moved. Suppose this is the 2 meter. You have to calculate the work done through the displacement. So calculate the work done through this displacement. Through this displacement. So the particle is here or the object is here. You applied the force vertically upwards, but due to gravitational force it came downwards. Okay, and the displacement starting point ending point. Suppose it traveled 2 meter. The displacement it traveled 2 meter. Then you have to calculate the work done through this displacement. So we know that this W is equal to force into displacement. Okay, I can write that F R cos theta. So here force is how much? 10 Newton. Displacement how much? 2. This is cos 180 degree. So this is equal to 10 into 2 into cos 180 degree. This is equal to minus 1. Okay. Newton meter. So I can write this is minus 20 Newton meter, or you can say this is minus 20 joule of work is done. So children, I hope that you might have understood this class thoroughly, and I expect that if you have doubt, you can comment through the telegram. So this is for today. I hope that you might have understood it thoroughly. Jai Hind.